Number 13. Given Pn equals 150, where P is a prime number and N is a natural number, which of the following must be true? A. P is a factor of either 10 or 15. B. 10 is a factor of N. C. N is a factor of either 10 or 15. Or D. 15 is a factor of N. There's a lot to this problem. I'm going to suggest a strategy of coming up of an organizational system. This is how I organize this problem to help me answer it. First, it tells me that P is a prime number and N is some natural number, and when I multiply them, I get 150. Now, I don't know what P is. It's some prime number. And N is going to be some natural number. And that's going to make 150. Well, I want to know, first I want to know what P's are in 150. What prime numbers are there? So I'm going to factor this out through prime factorization, find out what I'm dealing with. Let's see, whenever I have a number with a 0 at it, I can pull out a 10. Pull out a multiple of 10. Makes it a lot easier when I do my factor tree, my prime factor tree. Okay, so 15 is made out of 3 and 5, and 10 is made out of 2 and 5. So I could rewrite the prime factorization of 150 is 2 times 3 times 5 to the second. So, if I'm looking at distinct prime numbers, 2 could be a distinct prime number. Another distinct prime number is 3, and another distinct prime number is 5. Draw my little line here. Alright, so if P is 2, do you see what I'm doing here? Trying to find out, I find the prime factorization 150. Now I'm working backwards to try and find out what makes, what two numbers, when I multiply them together, get 150. So when I found out that 2 is a prime number that's inside 150, then the natural number must be 75, because 2 times 75 equals 150. Well, I could do the same thing for 3. If 3 is the prime number, 3 times what gets 150? 3 times 50. So N could also be 50. And the last one, 5 times what gets 150? 5 times 30. 30 is my natural number. Oops, gotta recharge this in a couple moments. Okay. If you can get this far in the problem, you're really close to solving it, because now we have organized what our prime numbers are and what our natural numbers are. So let's just work through these one by one. P, which could either be 2, 3, or 5. P is a factor of 10 or 15. So let's see. Here's my 10 or 15. 2 goes into 10, that works. 3 goes into 15 is a factor of 15. And 5 goes into both 10 and 15. So A is the correct answer. Now, let's just make sure we're 100% on that. We know that A is the correct answer because P, the prime number P could either be a 2, a 3, or a 5, and these are all factors of either 10 or 15. 10 is a factor of N. Well, if 10 is a factor of N, and here's my N, 75, 50, or 30, 10 is definitely a factor of 50, and it's definitely a factor of 30. but not 75. So not in all cases. Not when n equals 75. Eraser time. Oops. Okay. So we cross that one out. N is a factor of either 10 or 15. Well, that really doesn't make sense. That's saying that n, which is 75, 50, or 30, is a factor of 10 or 15. Remember, the smaller number goes on the bottom and the larger number goes on the top. These aren't factors. No. These are multiple. These are the factors. 10 and 15 are factors of these guys. 75, 50, and 30 are multiples of 10 and 15. C is incorrect. Clear that. And lastly, 15 is a factor of n. Well, 75, 50, or 30. 15, yes, it is a factor of 30, and it is a factor of 75, but it is not a factor of 50. So I get to cross out D as well. A is the only answer that works, where the prime numbers 2, 3, and 5 are either factors of 10 or factors of 15. And this is a very important construction, either or. It means it only has to happen to the prime number only has to work for one of them, not necessarily both.